Hello, welcome to the overview of the architecture diagram of the patient summary application. So in the patient summary application, the UI seems very simple to use. Uh, if you look at here, it has the search bar, it has the categories of the patient, and it has a summary will be provided in the middle portion of the UI, and the doctor can chat with the chat bot for any questions. So the UI is pretty simple, but when it comes to the backend, it's kind of a little bit tricky, and I'll be deep diving into all of that. So, so this application is especially for healthcare providers, doctors, for easily get the summaries for the patients, for their recent visit history, and for their previous all of the history of the allergies, encounters, conditions, observations, and anything, any records from the patient, and get summary out of it, and patterns, and any metrics that we can get out of it. So this is the overview of the idea of the application. So when it comes to the architecture, so I've used Ubuntu, where I've installed Rockham in it, and I have a UI application where I've used React for that. And if you see in the UI has different components like patient search. So we can search patient with patient name, patient ID, and get patient information. And you can get the recent visit history, and you can get the allergies, and like patient has different categories like care plans, conditions, encounters, immunizations, medications, observations, procedures. And you can get the summary for any of the categories of the patient. And for the healthcare provider, if they have any queries regarding any technical terms, technical jargons, or for such any medications, anything regarding to the healthcare, they can able to chat with the medical AI agent, and they can get query back, responding back from the backend, and they can interact. It's a two-way communication. They can interact with each other. So let's start with search patient. So for the search patient, so I've used Elasticsearch for the metadata, for the first name, last name, and the patient ID, and saved into the Elasticsearch. If you can see here, yeah. So I saved the metadata in this format so that I can easily get by ID. I can easily indexed with the ID, and for the fastest retrieval for this search. Uh, so that's what's the flow is happening. It's a search going to the fast API through the search API endpoint, and it is going to the search API code, and search API will go to the Elasticsearch patient for metadata. So after it goes to Elasticsearch metadata code, it will query from the Elasticsearch, and then it will be retrieved. If the ID matches, the related patient meta information will be retrieved. And for now, I'm sending back 10 similar records back so that I can see in the drop down like this. Once the patient is selected from the drop down with his first name, last name, and the ID, and you can immediately get the recent visit summary. So whenever the patient came at the last time, we're gonna get all the records from the Elasticsearch, and uh, we generate the summary. So let's go to the flow. So for the visit summary, it's a little bit different than search patient. It's just an API. For the summaries, for generating the summaries, it's a two-way communication. We are using WebSocket, where it has for generate, it's the endpoint is WS generate summary. We'll be sending the patient ID to it, if it's just a recent summary. If we are looking for exclusively for any categories, like all these things, we'll be sending this category name as well, so that we'll know which category doctor want to know summary of. So this two-way communication. Um, so the React and the backend will be like WebSocket will be communicated, like the two-way communication will be established, and so once a WebSocket connection established, we go to the code for the summary of the WebSocket, and once we know whether it is just the recent summary visit information, or if it's exclusively any category, based on that. So let's say if it is for recent visit, it will go to its specific prompt templates, which I've refined a lot when I spoke to doctors and healthcare providers and medical experts about these templates, and getting a feedback from them and changing the templates back and forth. So I've finalized my prompt templates in order to get the recent summary. So I'll be getting with the patient ID, I'll be getting the recent visit summary of the patient, which is a retriever. So with the recent visit summary, so I will be augmenting with my prompt template with that data. So I'll be appending those two and sending the augmented query to OLAMA server. So once I query the OLAMA server, so it will be connected to AMD Radeon Pro W7900 GPU. So once I have a query, it will be pulling one of the specified local LLMs to the server, and it serves and it generates the response. So I'm using response as a stream instead of a whole message to make look and feel good in the UI. So my messages will be in the stream way. It will continuously update. So that is one thing. And yeah. So once I get the response back, so WebSocket connection will be already established. So the stream of the messages, each token will be updated in the UI continuously. I'll be appending into the UI and make it in a proper way. So for example, like this. So when it comes to specific category like this, so if the doctor want to look into any specific categories like allergies, care plans, conditions, encounters, any of these, or like the total history of that, we gonna use a separate function, which is Elasticsearch for each category. So I'll be sending the patient ID and category to the backend. So my Elasticsearch has a query which retrieves exact same category history, and then with that data. So I'll be augmenting that to specific category prompt, and with that augmented query, I'll be sending to the Ollama server, and I'm getting the response as a stream. So yeah, that is a thing. And yeah, that is the flow of end to end of the application. So for yeah, and also yeah, about the chat application. So the user can able to send the messages back and forth using this chat bot. It specifically focus on only the healthcare domain questions. So if you if anything deviates from healthcare questions, it won't answer. So I made sure it was like that. And even for the chat, uh, since chat doesn't have any templates like the summary, so the API endpoint with the llama is also different. So chat also will have two-way communication. It has a WebSocket, and once the user queries the questions to the chat, it goes to the chat code, and it will directly go to the Ollama. The query will be go sending back to the Ollama, and the response will be in the stream format. And even in the chat session, the responses will be updating continuously. So another extra thing I've added. So whenever there is any disconnection happens between front end or the back end, so the connection will be automatically reconnected, so that uh, the communication will be established all the time. Okay, so yeah, let me go to the GPU metrics and then how I process the data. So yeah, so while doing this serving, while like while generating the response, while querying, while sending the response in the stream format, so I have tracked how many tokens are sending, how many tokens per second, what is the GPU utilization, what is the VRAM, what is the fan speed, what is the power, what is the memory utilization, GPU utilization, and like what's the prompt evaluation durations per second. So all that information I have customized and logged into WNB. All these GPU metrics, everything is logged into WNB. So if you okay, this usually look like this. So all the metrics, if you see charts per token, the power, the GPU utilization, evaluation duration per second, total duration per second, network traffic, everything will be logged. See, if you see tokens per second, yeah, chat prompt evaluation per second, VRAM, memory usage, load duration. Yeah, since we have so I've separated the chat API, the WebSocket querying, and the summary generation querying separately. So that's why we have different logs for both of them. And so yeah, that is WNB. And then let's go to how I process the data. So yeah, so I have gone through different resources in order to get the data. but I haven't got enough information from any of the resources I found. Then I finally found a synthetic data, patient data generator, and it provided me like 161 gigs of data, which is like good amount of data. So all the data is in FHIR format. If you're wondering what FHIR format is, it looks this way. So it has all the like links, all, yeah, like all the IDs, different kind of IDs, full URLs, a lot of things will be there. So I had to clean all these things, and then I made a CSV. The CSV, I took only the fields which are necessary. So like for a test, I've started with saving all the CSV information into the tables. I got very low speeds. Low speeds, what I mean. So every time I send the request, I got the response in like 20-25 seconds. When I use tables, I found it very slow with the GPU that I have. It's not the GPU fault, it's the how I'm fetching the data from the tables. It is taking so long. So I found another way. Like first I've gone through that way. I found another way. I started with embeddings and I tried to search with patient ID, and it was giving other patient information. So I stopped using that as well. So and finally I stick with Elasticsearch, which is giving me exact uh, patient information that I querying for. So I stick with that. And so yeah, so after cleaning into the CSV format, I've made patient's metadata, which I've showed here, and send it to Elasticsearch with patient meta as index. That is one thing. And yeah, so since the data is so large, so I tried pandas, which didn't work out for me. uh, it took a lot of time to load and query, but when I start using polars, things are very quick and made my life easy. So I've loaded the polars, all the files that I have. So my files look this way. So yeah, my files looks this way. It will be in a chunk format. So it has some n number of records, and this folder has n number of records. So like I have total 12 different folders with all the patient information. So I had that information. So since the data is like allergies, care plans, all the categories are separate, and all the main patients are separate, and everything is separate. So in order to do better query and fast query, so I still need to process my data as like grouping the patients into one JSON, so that I can able to get information relatively quickly. So for that is the reason I had to format each record for each patient, combining all the care plans, allergies, conditions, encounters, immunizations, like everything into one JSON. And I saved it. So when I use sequentially, it is taking like forever to do the work. So that's why I chose multi-processing in order to export my data into the Elasticsearch. So my new format of the data look like this. Yeah. So this is the Elasticsearch. So I have imported all my patients information, which is like 1.5 millions of patients. So if you look at this, let's, yeah. So yeah, if you see, this is a patients, which is we are starting with the patient. So it has the patient information. It doesn't have allergies, so we didn't add any allergies. So the patient has care plans, conditions, encounters, immunizations, medications, observations, yeah, procedures. Yeah, everything, every category which is related to patient is in one place. So that made my life very easy for querying. So once I retrieve like proper response, so now I'm able to quickly get the response from the Olama once I've done this uh, proper formatting of the data. And yeah, finally, so I've tried and tested uh, with all the LLMs. So these two LLMs say they've trained on medical data, but when I see the summary, it's not that great. So I've started using Llama 3, which is giving me like good results. So since Llama 3.1 released recently, so I've started using 8B in the beginning. Um, I'm getting better results than Llama 3, but I've started using 70B, um, 70B parameters. It is doing really quite well than everything. So kind of stick, I'm gonna stick with this. So yeah, yeah, I think that's all the architecture diagram. Thank you so much.